Time series forecasting refers to the type of problem where we have to predict an outcome based on time-dependent inputs. A typical example of time series data is stock market data, where stock prices change with time. Similarly, the hourly temperature of a particular place also changes and can also be considered as time series data. Time series data is basically a sequence data. Hence, time series problems are often sequence problems. Recurrent neural networks, RNN, have been proven to efficiently solve sequence problems, particularly long short-term memory networks, LSTM, which is a variation of RNN, is currently being used in a variety of domains to solve sequence problems. Next, we will discuss different types of sequence problems. Sequence problems can be broadly categorized into the following categories: one-to-one, many-to-one, one-to-many. So what is one-to-one? Where there is one input and one output. Typical example of a one-to-one sequence problem is the case where you have an image and you want to predict a single layer for the image. This is many-to-one. In many-to-one sequence problems, we have a sequence of data as input and we have to predict a single output. Text classification is a prime example of many-to-one sequence problems where we have an input sequence of words and we want to predict a single output tag. Next is one-to-many. In one-to-many sequence problems, we have single input and a sequence of outputs. A typical example is an image and its corresponding description. Many-to-many. Many-to-many sequence problem involves a sequence of input and a sequence of output. For instance, stock prices of 7 days as input and stock prices of next 7 days as outputs. Chatbots are also an example of many-to-many sequence problems where a text sequence is an input and another text sequence is the output. In this video, we will see how LSTM and its different variants can be used to solve one-to-one. As I said earlier, in one-to-one sequence problems, there is a single input and a single output. In this video, we will see two types of sequence problems. First, we will see how to solve one-to-one sequence problems with multiple features. Let's first import the recursion libraries that we are going to use in this program. So how to solve one-to-one sequence problems where input timestamps have multiple features. In the script, we create three lists: x1, x2 and y. Each list has 25 elements, which means that the total sample size is 25. Finally, y contains output x1, x2 and y. Lists have been printed here. You can see here. Each element in the output list is basically the product of the corresponding elements in the x1 and x2 list. For instance, the second element of the output list is 24, which can be product of the second element in the list x1, that is 4, and the second element in the list x2, that is 6. The input will consist of the combination of x1 and x2 lists, where each list will be represented as column. Here the x variable contains our final feature set. You can see it contains 2 columns, that is 2 features per input. As we discussed earlier, we need to convert the input into 3-dimensional shape. Our input has 25 samples, where each sample consists of 1 time step and each time step consists of 2 features. By using stacked LSTM. Let's now create a more complex LSTM with multiple LSTM and dense layers and see if we can improve. The model summary is given here. The next step is to train our model and test it on the test data point, that is 5580. To improve the accuracy, we will reduce the batch size. And since our model is more complex, now we can also reduce the number of epochs. The next script trains the LSTM model and make predictions on the test data point. This will take some time. In the output, we got a value of 3,705, which is still less than 4,400, but is much better than the, when we compare with a single LSTM. You can play with different combinations of LSTM layers, dense layers, batch size, and the number of epochs to see better results.